Once again, welcome everyone to our module 1 of circular buildings training. We just started our record, sorry for that, but yeah, here you can see our agenda for today's training. So we will start with the welcoming word and short introduction into OIKI and OIKI program and OIKI Serve project, so that you know what it's all about and why we start this training series, circular buildings. Then we will go to the presentations of our valuable experts. We have 4 presentations, as you can see. I will come to this a little bit later, when I will present also our speakers. Then you cannot see it, but we will finish with a discussion. We hope that you will have lots of questions to our speakers. You will be able also to raise your questions to the speakers after each of the presentation. But in the end, we will also have a little bit of time for questions and answers if you have, and we hope you will. And then we will wrap up our training module and will indicate our next steps in this project. Okay, so my slides don't want to change now. Now, so I think I will give the word now to Julia Weibel, the junior advisor for communication, representing German international, I don't know, GIZ. Julia, maybe you can tell a few words about the program.
Yes, thank you very much. Good morning also from my side. My pleasure to be here. My name is Julia, as you said. I'm working in the communications team of OIKI, and I just want to quickly introduce the program to you. The European Climate Initiative is a funding instrument by the German Ministry for Economic Affairs and Climate Action. Since its establishment in 2017, it has so far and ongoing financed 179 cross-border climate action projects implemented by various actors from non-profit organizations in civil society, the private sector, academia, and municipalities. The overreaching goal is to help reach the UE's climate targets. Through this undertaking, the OIKI already connects over 360 EU-wide organizations in its growing community. The OIKI works in 6 different topic areas: climate policy, climate neutral mobility, and also fostering the energy transition and climate neutral buildings in Europe. So therefore, the SURF project is of high significance, not only to reach these goals, but also to OIKI, and especially capacity building programs like this training series is of high significance. And we're not only happy to have you on board, but also happy to have you help reach these targets. And I want to take this opportunity also to announce that the OIKI will launch a new call for project ideas this November. So if you're interested and you would like to find out more, please follow us on social media, LinkedIn, Facebook, or as it's called now, X, formerly Twitter, to stay up to date, or visit our website where you can find out more about the projects and funding opportunities. We're very happy to support undertakings like this. It's one of many projects that focus on this topic, energy transition and climate neutral buildings. So I wish you a very interesting training series, many interesting discussions, an exchange of knowledge transfer. And yes, all the best for this day and the next series to come. Thank you so much.
Thank you very much, Julia, for this introduction into OIKI program. And we are very happy to be part of the project team, so to say, of OIKI with our OIKI-Surf project. And now I would like to give a short introduction of what is our project about before we start with the interesting presentations. As you, most of you at least know, the EU has a goal to be climate neutral by 2050. And this concerns also building stock, of course. And currently, however, EU building stock, more than 35% of EU building stock are older than 50 years. And around 75% are energy inefficient. And the building stock is also responsible for approximately 40% of energy consumption of the EU and also 36% of energy-related greenhouse gas emissions. So what are the challenges, current challenges for the achievement of this 2050 goal of climate neutrality? So first of all, currently only around 1% of building stock are renovated each year. And unfortunately, applied standards are quite often still incompatible with this climate neutrality goal. And renovation activities, moreover, are dominated by resource-intensive methods. And it has to be said that life cycle approach, which we, about which we will hear today, or circular solutions, are still not or barely reflected in practice in the EU countries. So this is the background for our OIKI-Surf project. So in this context, we started this interesting project. And the main aim of our project is to stimulate deep and sustainable building renovations by empowering municipal actors in EU countries, mainly 3 target countries, EU countries, Romania, Hungary, and Germany, but also other EU countries and beyond EU, to empower these municipal actors to foster and implement sustainable renovation projects. So today we start with our training series, the first module, as you already know, with the topic of life cycle approach and climate-friendly building materials. This module will be followed by 2 more modules in later stage of our project. I will come to this at the end of our training module today. And the second module will be focused on funding opportunities for sustainable renovations. And the third one on green public procurement for renovation of public buildings. So these topics have been identified based on a survey which we sent through to the municipal actors so that we can identify most relevant topics for local governments and other municipal actors involved in sustainable renovation, so that we can give them this knowledge and yeah, then they can act as multiplicators and transfer this knowledge further in their countries. So very briefly, so that you know the background of our trainings. And now I would give the word to our speakers. We will start the presentations with life cycle analysis of conservations versus demolition and new construction by using the example of a facade refurbishment measures. And this presentation will be given by Eva Maria Friede. Eva Maria Friede has been working as an architect and expert in sustainable buildings at Bauhaus Earth since May this year. And the focus of her work is on life cycle analysis and also planning and building with reuse and sustainable building materials, like, for example, wood, straw, and clay. And before she joined Bauhaus Earth, she worked for 5 years as a project manager at the German-Swiss timber construction office Weber-Brunner Architects, where on behalf of Berliner Senate, she developed a catalog of measures on sustainable and circular buildings in Berlin. And this presentation, which she gives us now, is also presenting results or key results of the research study which she conducted for this office, Weber Brunner Architects. So thank you very much, Eva Maria, for being here today. And we are very curious about finding more about life cycle analysis and also possibilities how to refurbish buildings sustainably.
Thank you very much, Yoga, for the introduction. I will try to share my screen now. So, can you already see my screen?
Yes.
Yeah, perfect. So, okay, today I will talk about the study I made for Weber Brunner Architekten, which was the focus on life cycle analysis of conservation versus demolition and new construction. And we were like focusing on a facade refurbishment of a family housing in Berlin. But first of all, I would like to mention some sentences about the current situation. Like maybe you already have seen these graphics. The environmental footprint of buildings in Germany is very, very big. So we have like 40% of the carbon dioxide emissions, 90% of the mineral raw material consumption, and 55% of the waste generation caused by the building sector. So it's very important that we act very fast and efficient to a more climate neutral way and to reduce like the waste of resources and to reduce like the carbon dioxide emissions. And I have also here like the zoom in into this 40%. Like you can see like around 13% of the carbon dioxide emissions are caused by the operating energy. So by, for example, heating and cooling and warm water of the building, but 27% are caused by indirect emissions, such as, for example, the production of materials. And in the last 20 years in Germany, at least, we were more focusing on like, how we can like reduce the operating energy, but we weren't thinking about the materials we are actually using and constructing in the buildings. Therefore, I prepared like this graphic which is like the material pyramid, and you can see that the bio-based and organic materials, they are more at the bottom of the pyramid, and they have like a low carbon footprint. Then the middle, we have like the mineral and synthetic materials, such, for example, bricks or also rock wool. And then on the top, we have like the metallic materials, which have like a very, very high carbon footprint in the production of the material. And this means that, of course, we should try to use as little as possible of these metallic materials or the materials which have like this high carbon footprint. And of course, we should try to let them as long as possible in a material cycle and reuse them. And here you can see like the material cycle when you have like at the beginning of the planning, you have your building and you are using a lot of primary material usually, but then you also have to think that in this moment you already construct a material depot for the future. So it's very important in thinking how the construction can be, and you should try to find constructions like plugging, doweling, and screwing, which you can reuse in the end of life of a building. So which you can easily put back in the material cycle and reuse in the next building. And that's something which at the moment doesn't happen so much. Often we are using like glue and composites, which are very difficult to reuse. Now about the life cycle analysis, I would like to show you how we were doing the calculation. There are a lot of rules and laws, and of course they are a bit different from country to country, but many things are also similar. So the LCA is the life cycle analysis, or also life cycle assessment. And the aim of the life cycle analysis is to take a holistic view of buildings, of the entire life of the materials. So for the production, the operation, the maintenance and deconstruction, actually it can be considered in relation to 13 indicators, but we were focusing now in this study on the indicator of the global warming potential, so the GWP. But also we were thinking about the carbon storage for bio-based materials, which is very interesting because it could be to put the carbon right now in the buildings and store it for a while. We didn't consider the operating energy, so it's just like the focus on the construction, and the observation period of building life was 50 years, which is also a rule for the German LCA. And in Germany, we have like the ELCA tool, which is like an open source tool. And there you can make the LCA based on the data sets of the Öko-Baudat. Yeah, here I wanted to show you again that there are a lot of different indicators, and we are just focusing on the first one, so the global warming potential. Something when we are talking about the life cycle analysis are the modules. It's a very, very important part. And you see there's the module A, which is like the part of the production. Then you have the module B, which is the use, and the module C, which is like referring to the end of life. And also we have the D, which are the credits and the loads of reuse, recovery, and recycling potential. And actually in Germany, we are focusing on the one which are black now when we are doing the calculation. And the others are apart, but not in the number we are seeing later in the presentation. Now coming to the example of this life cycle analysis and of the facade refurbishment. This is like the building we were analyzing. So it's a very high 9 stories building in Berlin. So we have high fire protection. We have to think about because it's very high story building. It's a brickwork work construction with sand lime bricks, and at the moment it's uninsulated. And the gross floor area is 12,600 square meter, and the facade area around 7,000 square meter. And also there is like a thermal insulation standard we have to reach, which is more or less 0.2 watt per square meter Kelvin. So then we were focusing on different scenarios. The first one was like the demolition of the existing facade and a new construction of the conventional facade. You have to think we were just focusing on the facade, but of course it's something you also can scale on the whole building. I mean, it's more or less in the end we have like numbers which you can compare. And so that's the first scenario. What happens if I do a new construction with conventional material? The second scenario is I will do a demolition of the existing facade and I put a new building, but an ecological facade, so a timber frame construction and a cellulose blow-in insulation. And scenario 3 and 4 were what happens if I do a refurbishment. So I let the old facade and I put a new insulation in front of it. The scenario 3 with a conventional refurbishment. So for example, with styrofoam, and the scenario 4 with a complete bio-based construction. And here you can see the results of the LCA, of the global warming potential. The first two are very, very high. In the gray one, you also see like the gray emissions the old building already, or the facade already has. And then the red one is, which is on top for the new construction. And then in the refurbishment, you see that you can save around in between 79 and 89% of the carbon dioxide emissions. Like the demolition and the new construction were so high comparing to the refurbishment, we then were focusing on different scenarios of the refurbishment. So what material has which carbon footprint? And often they were asking us if it makes sense to have a thermal refurbishment. And here you can see in the red line, the operating energy and the emissions of the operating energy if you don't do anything. So if you let the facade how it is. And then in the blue lines, you can see the operating energy is much lower if you have a thermal refurbishment. So yes, it really makes sense to have a refurbishment in the old buildings. And now you see like different building components we were comparing. So all of them are now refurbishments. The first one is like the conventional one, a composite thermal insulation with styrofoam or rock wool. Then we have the option to do a composite with wood fiber, or there are the options with a timber frame construction and insulation with wood fiber and hemp fiber, which are like a lot of bio-based materials in the construction. And here you can see that we can save a lot of carbon dioxide emissions if we go to a bio-based solution. On the left side, you see like the first scenario, so the conventional one, which is like at the moment the most common one. And on the right side, the one with the hemp fiber and the timber frame construction. And we were focusing also on the carbon storage capacity, not only at the global warming potential. And in scenario 1 and 2, you don't have any carbon storage capacity, like we have just synthetic and mineral materials. In the scenario 3, you have a bit because we have the wood fiber in the facade. And in scenario 4 and 5, we have a lot of carbon storage capacity. Like we also have like our timber frame, which can store carbon. Then we compared like on the 5 different refurbishment options to different indicators. So we have first the global warming potential, then we have the carbon storage, we have the cradle to cradle. So can we put it back easily to the circularity, and then also the ecology. So are there any glues or pollutions in the materials? And on the left side, you see like, and we tried to evaluate this with a traffic light system. On the left side, you see that everything is red. So the composite with the styrofoam, it has like a lot of carbon dioxide emissions. We don't have any carbon storage. It's very difficult to recycle and to reuse the materials because we have this composite which is glued. And of course, we also have a lot of pollutions in the different materials. And in Germany, it's very common if you have styrofoam and all these glued materials to put it sometimes also to the landfilling and not to recycle it anymore. Especially this is also the case with rock wool. On the right side, you see the bio-based solution, and here everything is green. So we have a very low carbon dioxide emission. We have a high carbon storage in the materials, we can reuse it if we are thinking in plugging, doling, and screwing when we are doing the construction. And also the hemp is a pure ecological material without any additions. So then in the end, like you already have mentioned in the introduction, we want to try to be climate neutral in 2050. So this also, of course, refers to the building sector. And there's a very interesting study, the CREM study, Carbon Risk Real Estate Monitor study. And they were focusing on different scenarios, how to reach the 1.5 degree and the 2.0 degree goals. And it's possible to get also the number there for the residential building in Germany, which here is marked in blue. And the calculation says that between 2019 and 2050, we still have 638 kilograms CO2 equivalent per square meter. And of course, like this graphic is falling. So every year you have less. So 2019, you have 42 kilograms CO2 equivalent per square meter. But in 2050, we already have to be more or less climate neutral. With this base, we tried to compare our facade solutions and put like the 1.5 degree goal. We tried to calculate where it would be in the refurbishment of our facade. And there you can see that the two options of demolition and new building, they are like above this 1.5 degree goal. And all the 5 refurbishment solutions, they are lower. And of course, we always should try to reach the climate neutrality. So we should always try to use a solution with a lot of bio-based materials. And also this slide says that it's very important actually to protect our building stock and to not demolish it, because there's already so much gray emissions, so many gray emissions and so many gray energy that we should try to save this and to not demolish it and build new ones. Yeah, that's all from my side. Thank you very much.
Thank you very much, Eva Maria. It was really interesting to find the importance, of course, to understand the importance of life cycle approach, using it in new constructions, but also in the renovations, and also the importance of using bio-based solutions when renovating the buildings, and also that it's important to rather conserve the existing buildings and to renovate them instead of demolishing them, and this way to hinder emission further emissions. I don't know to save CO2 emissions. I wanted to say. So thank you very much. And now I would give the platform for the questions. If you have some, feel free. We would give like 5 minutes now. I see already the first question from Christoph Backhaus. Yeah.
Hello. I would like to know if for the version with the hemp fiber, the total CO2 life cycle of the hemp has been put in that equation. So, because you are only using the shards, right? So you are only looking at the CO2 value of the shards. But what about the leaves, the seeds, or the other products? They also go into the marketplace. Are those also included in that CO2 calculation?
Well, a very good question. Actually, the hemp is a very specific thing, because in the Ökobaudat we don't have already the numbers. So we had to find numbers we can compare, and we had to ask like companies which produce the hemp. And usually it's so that you have like the production and the transport to the fabrics and so on included. But I can't say if the seeds are already there. But what I can mention is that I think it's not so much comparing, for example, the production of concrete or brick where you have to where you have a lot of energy to produce it, because you have like for the brick you have to fire it at 1 million degree. 1,000, not 1 million, 1,000. Yeah. Thank you.
Yeah, I'm a hemp activist, so I'm always interested in seeing stuff like that. But to me, if that is not taken into account, the equation gets kind of balked, because like the leaves alone are the best material for producing bioethanol. So if you take that part of the plant in the same production cycle, you have CO2 offset in a whole different sector of the marketplace. But that needs to be put in the calculation of the basing of the building, because it is a total of the plant. Like if the plant is produced, it's not just the CO2 that you put into the building, it's the whole CO2 that it gets consumed by the plant that needs to be put in the equation of the total life cycle of the building. Right, say what I mean?
Not exactly, because what actually is in the life cycle assessment is like the carbon storage which you have. So of course, when the leaves are storing the carbon, it's already in the calculation. Okay. That's why we have like this big carbon storage in this solution. It was the highest one, I think, or more or less the highest one, because because of the hemp, you know?
Yeah, of course, but again, the question here is it, see, this is the problem that I see many times made. Like if you compare it to, like, say, bamboo. Like, bamboo is extremely fast growing plant that stores a bunch of carbon, but you're using the whole piece of bamboo basically for producing the material. But in hemp, you can use so many parts of the plant, like the fiber, the stalk, the leaves, the seeds, all of those. But I usually only see them taking into account only the stalk, not the fiber, not the leaves. So if you make the statistic, it looks like you're only sequestering this amount of CO2 really, but that's only the part that goes into the building, not the part that goes from the plant, but it's the total life of the plant that consumes the CO2. It makes a false impression if you show it this way, and it's not the total plant. Like, you're not taking the full plant and put it in the building, right? But still.
Yeah, I think we have to ask the companies which exactly they are using, and actually it can also be different from company to company. That's also something which you were mentioning now, which of course is when you already know which material exactly you will take and which company you will like ask for the construction material. Of course, you already can make a life cycle analysis much more like detailed.
Okay.
I think we can continue a little bit later, because we will have one presentation like from Michael Burchert, who will also talk about hemp. So I think he will answer these questions a little bit later to you. Just be patient a little bit. And because we still have 3 presentations, if you don't mind, we would continue now with the second one. And then at the end of our event, we can still discuss with the speakers and look also at the questions in the chat, you know, and then also raise these questions to the speakers. So now I would ask Dr. İpek Ölçün to give her presentation. Dr. İpek Ölçün is the managing director and one of the co-founders of the Industry Association for Clay Products. And she will talk, of course, like the name of the association also suggests, talk about possibilities to renovate with clay products. And in addition, Dr. Altun is a specialist lawyer for building and architectural law and mediator. And before becoming co-founder and managing director of the association, she held various positions in the field of construction already. So she worked, for example, as a research assistant at the university, as lawyer in a law firm which specialized on construction, was head of the German Market Surveillance Authority for Building Products at the German Institute for Building Technology. So now I give the word to you, Ipek, and thank you very much for being here today. We look forward, very much forward to what you say now.
Yeah, thank you, dear Yoga, for this kind introduction of myself, and a big hello to everyone from Berlin, from the sunny Berlin. I'm very happy to be here in the sense of sustainable buildings in the future. I would like to give you, before I come to the overview, oh, doesn't work. Just let me see. Try to change. Just a second. Will work for sure. Yesterday worked. Okay, great. First of all, I will show you our content for the next 10 minutes. Why an industry association? Because we are founded very new. And then I will give you an overview of the clay materials which are industrially produced in Germany and somewhere else. And so just go straight on. We are founded because we saw a lack for industrial produced clay materials. We are more than handcraft. Handcraft is very important, but we are already industrially produced, and we want to scale up that, and we want to ensure that we are seen by the building actors who try to get green and who try to get climate friendly. We are founded in end of 2022 to give, as I said already, a face, a voice, and visibility to clay products. And our mission is to promote a sustainable construction in that area. On this picture, on the first picture above, you can see the changing times. So back then, handcraft clay buildings made up in this way, and now you can see the real industry producing earth and building materials now in plants. And the next slide you can see, just to get an idea about it, where you can use the materials, which I will show you in the next slides. You have this view into a room where you can see all the materials you can use. You have clay dry building, you have masonry, you have rammed earth, you have fine finish surfaces in any color you want to have. We prefer the natural ones because you don't have to add any other things to it. Then you have clay plasters. You have for sure clay mortar to use clay bricks, which you can see on the right side. You can use it, clay building materials for insulation. And Eva Maria talked a lot of timber frame. You can use it in the timber frame restoration, but you can use it for new construction buildings in timber frame as well, very well. So it's not just restoration. Well known in these fields, in all of these fields are well known very lot of conventional building materials, and we're trying to get the site into the clay buildings, building materials. This is again just an overview, just a view into a room, just to let you know. So then there are a lot of variety of clay buildings. I would say there are 5 main products. You saw already all of them. in Germany, and that's the point where I would like to recur. You have clay stone and clay brick, and clay brick is standardized in Germany. You have the standard DIN 18945. Very important is, that's why it's written over there, that the products are always air dried. So you don't have a burning process, which is very high in emission. So you can use the bricks, which are air dried, inside and outside. We have a load-bearing code according to the Eurocode 6. Which says that you can build up in Germany buildings with 4 floors until 13 meters high. You have for sure standards again for plaster and mortar. Clay paint is not standardized, but you don't need that. Clay dry building is the green alternative in drywall construction. We are there, we need to be seen. The timber construction industry sees us. We have a lot, you have something to do and to change in the German regulation to get our place as a alternative in the field of using dry wall constructions. You can see we are for sure non-flammable. You can see here further some arrangements which was made by some companies of us about the fire resistance duration. You have the fire resistance duration E90 and E120 tested. We need some tests more. That's what the German regulation asks for, and we are on it. Why we should use clay building materials. As I showed you already, all the materials which you can use when you build up or when you renovate buildings. They're on, you can show that on 2 hands. We are very low in energy according to production procedure, because we are air dried. We are recyclable, reusable as well, regionally available, German-wide and Europe-wide, and I would say worldwide. Sound absorbing are one of our construction physically advantages. We are moisture regulating. This is a real point which timber construction and clay products go very well and hand in hand, and you can see that in buildings which are built up all over the world 50, 100 years ago. You have the pollutant regulating factor of clay products. They are heat storing, and they protect from heat in summer because of the heaviness of these products. So here just a few success stories. This is the Federal Ministry of Agriculture, Food and Consumer Protection in Berlin. And they use their dry building, in the dry building, about 4,000, 2,000 square meters of dry building. This is another success story which you can see. It's the Kreisarchiv, which means it's an archive for municipality in Germany, in North Rhine-Westphalia, and they use their clay building materials as well in the focus for the dry building. So this is another project which they try to use timber, brick which is burned, and clay materials to build up this kind of housing arrangements. This is to mess up later, not to mess up, to research on it, what is better in using, what is more climate friendly at the end. And last but not least, after my really fast, I hope I could take it in 10 minutes. please visit us on our webpage. You can follow us on LinkedIn. It would be very nice. We just introduced the LinkedIn page 2 weeks ago. And you can visit our members on their, our company members on the pages which are shown over there. Yeah, I'm happy to hear. If you have questions, just ask. Thank you for listening to me.
Thank you, dear Ipek, for this presentation and good practice examples, and showing that there is ways of climate-friendly renovation, for example, with clay products, and also for showing this good practice examples, how it can be implemented already in practice. I hope that some of you will be inspired by these examples. And now I would give a couple of minutes for questions to Ipek if you have, but please have in mind that we will have our discussions also at the end of all presentations, because I already saw in chat Michael tries to already answer some questions, and yeah, maybe some of the questions we can answer also at the end of our event. So Lucas Schmitz raised his hand. So Lucas, you can.
Yes, thank you. Yes, thank you very much. Yeah, thanks for the presentation. I am personally relatively new in this field of ecological or sustainable building materials, but what always comes across my road when I'm doing like research in that field is always this argument that it's so expensive to build with ecological materials. So my question is, how is that if we talk about clay materials? Is that a very is that a much more expensive material than the conventional alternatives, or because I can imagine that maybe here this argument is not so heavy as it is when we talk about very new invented products.
Thank you, Lucas, for asking for that. I saw just a few questions further in the meeting chat. I will answer them as well. But first, I start with you, Lucas. That's a very important point, and you are right. Like other alternative products, which are green, I would say we are more expensive. But if you compare that it's recyclable and that you can use it again, and that the energy is very low, which you need to use it, then if you look in the SCA, really, that's the next question, which is like Kit asked, and you will see that it relativises himself. So, and Kit, yeah, you, or was it Dieter, Maya, nice advertisement, thank you, on clay. And some LCA would have been nice. Yeah, they will come. We just, I showed you that we are just founded last year, end of last year, and I just started with the work 2 months ago. So I see that you are very curious about it, and they will follow. Thank you. And Kit, let me read. Did I read correctly in your previous slide that you had line plaster? GVP. Oh, sorry, that's not my point. That was worked out by the companies. I can ask them if this is right or where they recur to it. From our association, such slides will follow, but I am working on that very hard. So I'm really sorry, we're just new. So I can't check. I can't answer you if this information is right according to gypsum and cement.
Okay, thank you very much, Ipek. So if you're still interested in having this information, you will receive the slides afterwards, and you will have the contacts of Ipek, and then you can contact and raise this question bilaterally, of course, and she will give you an answer. So thank you, Ipek, once again. And now I will give the word to Michael Burchert. he will answer, I think, some of the questions already raised in the chat. Michael is a CEO of the think tank Bouwende, which gathers different actors dealing with sustainable and climate-friendly construction. And Michael says that entering the construction industry as a computer scientist with a degree in social education may sound unusual at first, but when it comes to sustainable building with rapidly renewable raw materials, there are less technical problems than social ones in terms of widespread use. And that's why Michael helped set up the training department of the North German Center for Sustainable Building. And in the think tank Bouwende, he advocates for efficiency, sufficiency, resilience, health, and radical minimization of footprint of building, living, and working. So very happy to hear your presentation, Michael, now.
Yeah, thank you, Yoga. One thing first, I'm not paid. We're an independent think tank, by the way. And yes, climate positive techniques. Yeah, let's see what good news we have. Let's talk about, if my presentation starts, okay. Yeah, let's talk about huts. No, actually not. But we talk about the same materials, basically, just with modern building physics applied. Here you see a workshop situation. We basically started a school in Verden, in North Germany, the North German Center for Sustainable Construction, where people from all crafts and planning learn how to produce basically passive house ready modules, like modular building from low-tech materials, and we do this, we form this into high-tech, high-performance modules. This is actually an old technique. The oldest building in Europe is actually 100 years old. That's built with straw, and basically the same method, like a wooden load-bearing system and straw infill, directly plastered. And yeah, trick is to make it gapless and settlement free by using pressure. And you actually don't need any tools for that. You can use tools, of course, but you don't need this. And the trick is to have a density of around 100 kilo per cubic meter. This makes it very safe. And here you see engineers training in our practice hall and learning this. Yeah, it's directly plastered. That's a trick. This is the air air and wind tightness. Here you see the finished building. This is the North German Center for Sustainable Construction. It's 5 stories high and it's built with straw, clay, earth, and lime. And this is how it's made. You saw the pictures before where the students were practicing this. Here, 2 guys were practicing in the same hall you saw before. In 2 months, they built the whole house. Basically, they prefabricated these modules, and they actually applied the first layer of plaster, as you see, as a protection. And it's just stacked over each other, and boom, there's the finished house. I mean, it's very easy. It's very easy to build, very fast, if you know the trick. So yeah, we also showed this for the last maybe 10 years or so, also in vocational schools around Germany. We have thousands of people that can basically do this. We had 2 days with hundreds and thousands of people usually, and basically this is ready. And we also did this on training on actual construction sites. This is the builder's family from a 5 family home. They helped after a brief introduction, like 45 minutes or so, and they can do this in a quality way, and it saves a lot of money actually. Here we did this in Berlin on the street with refugees, like occupy parking space, right? Just no roof and quality passive house ready construction. And why are we doing this with straw? I mean, we can do with there are so many construction materials, right? But we have problems, right? We have our budget is actually our climate budget for 1.5 degrees is actually depleted in 3 years in the EU and UK together. So we have to act, and we can actually. I mean, you see it behind me. This is an old technique, and it just works, and it gives super high performance buildings. And yeah, still by straw. There's so many other ecological things around, right? Yeah, but the best material is best building material is the one that does not have to be produced. It's already available. That's a trick. And it's everything there, not just the material, also the research is done. I mean, it's passive house ready, it's certified. You have all your whatever heat bridging and so on. Everything is there in detail. You even have your BIM models ready. You can, I mean, it's almost completely open source, this technique, and it's super ready. Yeah, but for those who can build with straw, don't worry. Other plants have also beautiful fibers, right? There are a lot of plants worldwide. We saw hemp already. But if you look at the if you have enough, this was a question from the chat as well. There's I have to say yes, we have enough, but not from all species. Let's put it that way. And well, we have a lot of woody, not wooden biomass, but woody biomass, which I mean straw and hemp and so on. This is basically also woody biomass. It's the same, basically the same as timber from the forest. It's also cellulose, hemicellulose, and lignin and other stuff. But if you look at the demand and the supply on the top left there, there's a straw with this yellow color. You have this line, this is the supply. And the bars, the little bars, this is the demand if you would renovate all Europe with this material, right? So we have a much larger supply than demand. So we don't have to use it all and still have enough. This is basically what this is saying. And on the right, the green diagram, you have roundwood, which is well, forest products. And you see that if you don't burn this stuff, you also have enough for renovating all of Europe. And we have to renovate around 85% of Europe, right? We have a lot of old buildings that need to be retrofitted. And you can see that for cork, which is a great building material, and hemp, which is on the right, the blue one is hemp. You can also look at the scale, please. On the top, you have 1 million ton per year, and down there you have 1,000 ton per year. So it's not as much, and the demand is higher than the supply. So you can't build everything out of cork, and we can't build anything out everything out of hemp. But it is, we have to use it, and it's cool. But the top materials that we have to use are actually the straw and wood products. Now, so here's homework for you. You get the presentation afterwards. You can look at your national straw potential. I prepared this document. Yeah, another study looks super complicated, but it is not. I guarantee you. This is by Guillaume Habert. That's a great guy from ETH Zurich. He looked at how can Switzerland stay within its 1.5 degree budget. And he looked at construction, obviously, and he looked at the business as usual, and you see that it goes well beyond 2 degrees, so it fails. So if Switzerland continues to build like that and renovate like that with usual materials, it doesn't work. So he looked at many different options. You see this very complicated. He let it run, this model run several scenarios and so on. And he came to the conclusion that Switzerland has to control its embodied emissions, so embodied carbon, right? So there's no way around it. You have to limit that. So how can we do that? Yeah, we can ditch the bad stuff and go to the best performing things, right? This is pretty easy. I mean, the child would come to this conclusion, right? We have this emission scenario, they go up, and we focus on the things that go down. And you have several options, but straw is the best one, actually, as you see on the right. You have 88 kilo sequestration, storage, CO2 storage in the building. And hemp does this as well, but there are some differences there. Yeah, and this is not optimized for sequestration, by the way. You can store more. And this is also with lime, by the way, which is emission as well. Yeah, and this storage thing is interesting because when you have negative emissions, or let's say climate positive, there's a bit of a bad wording there. You can use these emissions directly in the building to offset things. Maybe, I mean, we can discuss this. You can even do an optimized reinforced concrete building and have super thick walls to compensate for that. You have these 1 meter thick walls there to compensate this. I mean, do not do this. Do it rather with timber. But with timber is also just not really a climate positive material. At least mass timber is not, and at the moment. And you have to compensate this with 40 to 60 centimeter straw bales, which is okay. This is a normal straw bale size. Here's another study that's very interesting to me, because we usually look at 50 to 60 year timeframes in construction, which is a bad idea actually. We have to look at longer timeframes, and we see here is a 200-year timeframe. Basically, it starts at now, like 2018, and here they looked for different renovation scenarios with different materials like styrofoam, EPS, wood, and hempcrete and straw. And here you see that EPS can never go climate positive because it's just an oil product. It's a fossil oil product. It's just emission. And you look at timber. This is the brown thing, and you see it dives under zero very, very late. I mean, 2150, because a tree obviously needs to grow back to its former state. It takes a long time. And you see that hempcrete is neutral, let's say, for, I mean, almost 100 years, and then it starts to dive really, really good. Yeah, this is because there's a large lime part of this, and straw doesn't have that. It can have that if you do a plaster and so on, but you don't have to. And straw is directly positive, so to speak, after 1 year, because its crop grows back, like hemp, and so on. So another study, I don't want to bore you, but this is really interesting stuff. So we have this two buildings compared here. You have this B2226 and the solar house. The B2226 is maybe the best brick house you can build. This is a brick house. These are larger houses, multi-story. This is a house that doesn't need the heating, and the solar house is a straw house. So, and the first bars, there's again, Guillaume Habert did a research, what is the sustainable budget for construction, for new construction. And he found these values to be in line with sustainability. And there's also the ZIA target, which is a Swiss target for limiting embodied carbon and whole life carbon. And you see that the brick building, the 2226, this is too high. So the best massive building, basically with burnt brick, with fired brick, can't achieve this. This is just too much. And you see that for the straw building, you can actually lower the thresholds. You can even go below that. So, and how to do that? Here's from Atelier Werner Schmidt in Switzerland. You can do it like that. I mean, just put the bales at the wall. This is called wrapping. And this is plastered, and boom, you have your passive house wall. This is great for summer and winter performance. This is a usual bale, and these are very thick ones. I guess that these have around 16 hours. They add 16 hours amplitude dampening, so you won't ever have a temperature higher than 23 degrees or so in summer, even in a heat wave.
Michael?
Yeah.
I would like to ask you to come to an end,
okay.
Because our next speaker, Dominic, has to leave sharply on 12.
Okay.
So maybe you can take this into account. Thank you very much.
Okay, so I will just hop through the next one. I mean, you don't have to do this by hand. You have a lot of prefabrication already. You can really order your panels, as you see. And this is Oberhausen. They retrofitted 5 swimming halls with this, and easy. You can see it's just bolted on, and there you have your swimming hall. Here's in Paris, 3 kilometers from the Eiffel Tower. It was retrofitted. Just strapped on belts with some tie bands from logistics and plastered. This is fire tested in every country, basically, almost, and proven. You can retrofit with hemp, obviously. Just have some shuttering there and plaster over it with clay, and you're good. You have your industry that's also ready. Your concrete industry, they do hemp bricks, like no problem. Where's the problem? Same infrastructure. It's carbon negative as well. You can have your WDVS, your external wall insulation system, plaster over it, ready. You can have your walls easily retrofitted with belts, with standardized. I have this console here that you can screw on the wall, and you are good. This is pretty easy. It's pretty doable. This is the finished house. Or do a large scale in industrial retrofit. Just do large modules, crane it in place, and you have your new building that is ready for the next generation. Thank you.
Thank you very much, Michael. I would now give the word to our next speaker, unfortunately, but thank you very much for all these climate-friendly possibilities you presented. I think it's very interesting for everyone, and I'm happy that we will be able to give this presentation, to put this presentation online for you. So if you have any questions, please contact directly also Michael afterwards. But Michael, I hope you will stay by the end, and then we can give you questions at the end of our event after the presentation of our next speaker, Dominic. Dominic Campanella is the CEO and co-founder of Berlin-based company Concular, and the brains behind their tools designed to cut GHG emissions from the construction industry by 20%. And his commitment to fighting the climate crisis propelled to harness the power of digitalization to understand the material structure of our built environment. And in doing so, he's making embedded carbon a talking point and paving the way to circularity. So now we will hear an interesting presentation about circularity in the construction and renovation projects. Thank you very much, Dominic, and I give the word now to you.
Yeah, thank you, Yuka, and sorry, Michael, to cut you. I have another meeting at noon, so sorry for that. Yeah, as already said, I'm one of the co-founders of Concular, and Concular we describe as a digital ecosystem for software construction. And what we believe in is that these methods, which the presenters before presented, are really, really important. And when you combine it now with the digital tools, you can really enable the complete, you can really enable this in a much higher scale. And I mean, the problem we have, I think, was explained already before quite often. So we have a huge issue in the construction sector, as we have the highest amount of waste and also GHG emissions. And as also already said, like the big issues to make waste principle, right? We take resources out of our earth, we produce materials, we put them into buildings, and sometimes after just a couple of years, we take these materials, which in a really high quality, and we throw it away or we downcycle it. And this cannot be the case anymore, because we have to change, we have to think in circles. So that also means that we have to look at buildings in a complete new way. So we have to look at buildings as a source for new products and for new buildings. And as also already mentioned, is that we have to actually follow the circular economy principles. So so far, when we talk about circular economy, or at least in Germany, very often the discussion is going into recycling. But what you can see here is that the biggest impact is actually, first of all, if we refuse to build. So the best building or the most sustainable building is actually the building which was already built, right? And so we have to refuse to build something new. We have to refuse to deconstruct, actually. And if we build something, we have to reduce the amount of resources we take. We have, of course, to work much more with bio-based materials and so on. And if then in the next step, and this is then where Concula is coming in, is that we have to reuse materials or refurbish them, and only as a last resort, we should think about recycling. And when we think about recycling, then we have to think about a high value recycling and not a recycling which is decreasing the value of the material, which is happening, unfortunately, mainly today. So if you look at the pyramid, you can actually see that most of it is happening at the last step, and there in downcycling. Also, the biggest aim is to go much higher. So we discovered that already more than 10 years ago. And what we thought, like, okay, so on the one side, buildings are getting deconstructed. On the other side, we need these materials for new construction. So why not match supply and demand? So why not build a marketplace where people who have materials as a leftover from deconstruction can put it in and others can buy it? So we founded Tristado, and we built it as the largest marketplace for circular construction in Europe. What we then discovered is that this is working really well. However, this is only working for private people, because when you look at the large construction projects, the marketplace is not enough. I mean, you don't buy your materials for large projects on a classified ads website like eBay or so. So you need a certain quality, a certain quantity at a certain time with the warranty and so on. And this is not what the marketplace can deliver so far. And this is why we thought, like, okay, we have to bring a specific solution only catered to professional actors in large buildings in the construction sector, which we then name Concula, where we have the whole process and not only a marketplace, because we need the process before and so on. And what we actually did is we went to a lot of these professional construction companies, and we asked them, like, why are you not reusing or recycling construction materials? And so we gathered a lot of answers and especially challenges. And what we identified as the main hurdle is that we just don't know what's in the building. So right now in every building you are, no one knows actually what's put in that building. So what we, and then when there's a deconstruction happening, the construction companies coming in, and then it's too late because they don't have time to really look at the materials and then to see where can we put the materials and so on. They're doing it in a very rough way, but not in a granular way where there's a high possibility to really have a high quality reuse of the materials. And this is why we thought then, okay, we have to digitize materials in new and existing buildings. For new buildings, most of it is planned in BIM. So we are able to upload the BIM model on the platform, and we can digitize and do a lot of calculation, like embodied carbon or like a whole life cycle calculations can you do actually on the Concula platform. Also scenario planning, saying like, I want to reach this goal of GHG emissions per square meter and so on. And then it's getting optimized. But the big impact also lies in existing buildings. So how can we reduce or how can we digitize materials in existing buildings? And for that, we developed a software, basically, which you can put on your phone and go through the building. And what we also do is like 3D scans. So really looking with a 3D scanner and kind of computer vision algorithm what materials are in a building, and then automate this process. Because when you think about, okay, I have to digitize materials in existing buildings, that seems to be a large task. But with software, you can reduce this complexity and make it very simple. And I think this is the key to scale it also to every building, actually. And then in the end, it comes down to data, right? So what we did at Concula was to build a large database, also partly from ÖkobauDat. So like it's a German database where we have a lot of information about how much GHG emissions or also different kind of emissions are in use for the production of some materials, so the embodied carbon, but also we have data about the circularity. And what's a really interesting aspect is also when you now take these materials and you sell the materials at the end of the lifetime of the building, instead of paying for the landfilling, you make out of the cost block something valuable. So you can make actually money with the circular economy. And this is something really interesting. And when you put all these data together, you have a really good picture of like what kind of materials can go where. Because when then there's a renovation or a deconstruction happening, we are matching the supply of all the data with the demand of manufacturers, recycling companies, building owners, and so on, to really close the material loop. And now, of course, a big point is also, can we do that from the construction site to the next construction site? This is often not the case. I mean, we are working a lot with manufacturers. We're taking that on their side, refurbishing it, and then selling it again. But sometimes this is also not possible. This is why we strategically now go from the digital space also in the physical space, creating so-called urban mining hubs. So we opened one here in Berlin. You can see that, which is 1,000 square meter of storage facility, which is also in cooperation with Alba, it's like a disposal company here in Berlin, and also the Senate of Berlin. And we will open many more of these facilities in Germany, so to enable also that we can even circulate more materials. And also these storages are completely run digital. So we have a software behind, which is then again connected to our system to have no friction in between, to make the process very efficient, because with efficiency you can reduce the cost and make then these materials cheaper than new materials, but with the big advantage that they have much less CO2. Now, this is all nice, and I mean, this is what we done from Concula, but we want, of course, that also others are doing that. And this is why we created the a DIN norm, or DIN spec for it. It's called DIN spec 91484, so-called pre-demolition audits, where we kind of standardize the whole process of what I just explained, and is free to download. Everyone can just apply that principle. It's also in English available, so you can just search for it and you can download it in English. And this is what we've done with 30 stakeholders in the construction industry, a lot of universities, but also practitioners and so on. And with that, there's two purposes. One purpose is that others can just do it also. But the second purpose is, in Germany, you can just demolish buildings without any permission. And I think this is not good. We have to really check before demolition, is there really a reason for demolishing a building? And what from the building can we really put in the circle again? So, and this is where this DIN spec is going into, and the plan of that DIN spec is to make it also as a European norm. So, but that, of course, can take a while, but I think this is a first good step. Also saying that this principle is working. I mean, we have done more than 300 projects. I will show you also some examples very soon. 2 million materials were circulated, and I think it's a lot about collaboration in the construction sector. So we try to collaborate with the 55 leading construction and real estate companies in Germany to make that possible. Right now with 65 people, 5 offices, and also as public and private clients. And it's quite interesting. We also have a lot of public clients like cities and so on, which are also quite interested in that, and with whom we are also doing these projects. But I think very interesting is to see how it looks in reality, right? So giving you one example, this is the former headquarters of Vodafone in Germany. It's in Düsseldorf. And this building will be not deconstructed. That's good. But the interior will be completely changed, because there will be some public administrative offices coming in. So what we've done here is that we went to that building. We did like our pre-demolition audit. So a lot of the materials were digitized. You can see, of course, because it's interior material, we have a lot of partition walls. We have a lot of these lightnings. We have hundreds of meters of these partition walls and thousands of lightnings, but also something like kitchen or like these stairways and so on. And then what we did was we went to all the manufacturers and we created take-back systems with them. So especially Lindner. Lindner is a complete or its own production line for reclaimed construction materials. So they take these materials, they refurbish them, and then they're selling it again. The same with Zumtobel, and so they're doing the lightnings. And working together with them and also ensuring that you have a good quality, we were able to put it on our platform and then sell it, of course, to new projects. And you can also see how then these materials were just put into another building. So I mean, most of the materials you just saw in the pictures are already part of other buildings now, which I think is a really big win. Yeah, you can, for example, see like this is how they put it out, and then they transport it to a new office. You can also see how kitchens were put into new buildings, or I think this is the doors which were used as, unfortunately not anymore as a door, but at least as some things where you can sit on. Another example would be a discount or like a supermarket chain, which are working together in Germany. So they always, for all the supermarkets, they always have kind of the same wooden structure. And these wooden structures are quite good. I mean, you can, what we do is like we put them out. Some of these wooden beams you can use as wooden beams again. But some of them, they have some how to say, they're not, cannot be used directly again. So what we're doing is we're working together with the company Trick Brick, and they're doing so-called bricks with that. So basically it's like wooden Legos, which you can stack on it. And then you can build complete houses with it. So you can see out of these wooden beams, a house was built. And the really good thing is that you can just take them. So if the house is not needed anymore, you can just take them out as Lego stones and take it somewhere else. So from sustainable materials, so wood, we use it as in a second life with a new product, and can be used again. So this is, I think, a good example. Of course, best would be to use a wood beam as a wood beam again, but this is also a possibility for high value. You can also see that also some other stuff was made out of the wood, and also like these stuff were also used again. So everything which was used there, or what was part of it, was used again. But we also do like not only interior stuff, but also outside. So you can see, for example, this school which were a lot of bricks. I think 20,000 bricks. And so the bricks were taken out of the school. They were cut as tiles, and then they were put on the same spot, because they demolished the building to put a lot of residential buildings on it. And now the facade of the residential buildings are based on the bricks. But you can also do a lot of interesting stuff if you have a digital inventory of the materials. So this is an example of the Karstadt Hermannplatz. It's a department store in Berlin, a very big one, 40,000 square meters. We went into it, we digitized all the materials, and it will be renovated. And now they created a competition for architects. These are all materials that are already in the building. Plan the renovation with these materials. And you can see some of the materials which were part of that. And so the entry, the competition entry with the material where they used most of the materials again won the competition, and it will be now renovated based on the materials which are already in the building. And another example where we were not involved that much, but this is our office. I can also, so if you at some point of time are in Berlin, I can just tell you, just come to visit us. This is the Circular House in Berlin. So this is a former storage facility of the brewing company Kindle. And so there were like beer which was produced there, and now it was not used anymore. And what the team behind LXSY Architects did was to really use 80% reused and reclaimed materials to build that. So 80% of the materials here are circular materials, and everything which is part here, and there's a lot of materials which we just heard about before, clay, hemp, and so on. Everything is also part of that. And everything is put in a way that you can take it out. So nothing is glued or so, but everything is screwed and in a way that you can basically take the whole building and put it somewhere else, which I think is a really good idea and is showing like how circular construction can look like. And with that, I hope I could give you some examples of like what is possible also with digital tools and encourage you also to do that in your countries. And with that, thank you a lot.
Thank you very much, Dominic, for this really, really interesting presentation and showing us the ways how it can be done. So I hope that everyone is inspired and will give this knowledge further of all the presentations, not only the last one. And now Dominic has a couple of minutes maybe for a couple of questions, and then he really has to leave. And then if you would like to stay, we would give a possibility to raise some questions also to other speakers, especially to Michael. Sorry for interrupting you before. So any questions to Dominic? Doesn't seem so, but you will have his contact as well at the end of his presentation on the last slide. So if you have any questions later on, I think, Dominic, you don't mind if people approach you on this interesting topic and on your work.
Yeah, perfect. You can just write me on LinkedIn also.
I think there is one question I can read. Do you have an integration to cut?
So we have we have a plugin to Revit, and we can work with BIM files, right? Or like IC files, so BIM models which can be uploaded on our platform, and we have an integration into Revit.
Okay, and one more question. Thanks, Dominic. How will this scale up across EU, collaboration with others, or franchising your model?
I mean, it's a good question. I mean, in the end, for us, it's important that it's also done in other countries. I don't care too much about like what kind of model it is. As said, like how we're doing it is open source. You can just use it. You can just put it in your country. We are working also together with like companies in Switzerland, Austria, and France. So I think that is something. So in the end, we have to collaborate, of course, like because we have to share knowledge and so on, and we also have to put some pressure on the European regulation, because this is a big challenge, I think, for everyone who presented here, that like laws right now are not really giving an advantage for what we're doing. So we have to work together to change that. But we are open for any kind of collaboration. And as said, like the companies who are doing that in other countries, we're working together. We're doing, for example, some cross country projects where we kind of like when we're on the French border, there's an exchange of materials and so on. So, I mean, that is very easy in the European Union. This is really good. I think also Chloe asked a question regarding material health. Actually, yesterday I had to talk with Nora, who's the founder from Pedal NGO, and definitely this is a big point. So, I mean, we take into consideration pollution reports, of course, like what kind. So we should not circulate materials who are polluted, of course. This is a big consideration, but material health is, of course, more than that. And this is something we are not taking into consideration too much right now. I think this is something where we can definitely improve.
Thank you, Dominic.
Yeah.
Thank you very much. So we will not keep you now, but thank you a lot.
Thank you.
And now we give a couple of minutes for the remaining questions to the speakers if you have, and sorry for lagging behind our schedule, but there's so much to share, and really, you know, it's hard, you know, to squeeze everyone in 10 minutes when it's so much to tell. And I hope that you will benefit from all this presentation and additional couple of minutes. And thank you to the speakers that you take this couple of minutes for the questions. Anything to ask?
I would like to add something,
Yes.
maybe because in the refurbishment, of course, we just were focusing on some materials. Of course, for example, clay is a wonderful combination with timber, and I think we really should like have in mind when we are building with new buildings to use more clay, because it has more mass, so we have we don't have the problem with the heating, like with the heat days. So I think it's very, very good, and also with the fire protection, it's a very good combination. And there was one question, like if we have enough bio-based materials for all the demand. Well, actually, it's funny that always this question comes, and it doesn't come when we are talking about like the conventional materials, because actually we don't have enough sand and oil for all the other materials. So I just wanted to say that at the moment I'm working in Bauhaus Earth and at a very big global study, and there we are exactly asking this question. So the supply and demand side of bio-based materials, and also of local materials which are available in the different regions. And then we will see what it means. Of course, we have to change a lot of processes of like the forestry and the agriculture and the value chain to get like the materials available. But actually, if we continue constructing like we have done it before, and in 2050, 2.5 billion more people will live in urban centers. And if we do the housing with conventional materials, 75% of our carbon budget is already consumed for their buildings. So maybe we should have this in mind when we are talking about the bio-based materials.
Thank you very much. And I saw that Ipek and Michael approved or agreed with you. And thank you for this thought, for sharing this with us. I think it closes our discussions very well. If there are no other questions, I understand that everyone wants to leave most probably to the lunch. It's lunch break. There's one question from Christoph, I see. Christoph?
Well, this goes to Michael. In your statistics for comparing hemp with straw, where does the wood come from? Because for the straw buildings, you need the wood, right?
When you mean where the cork and hemp and straw and wood was compared, this was look at the study. You can get the link afterwards. This is for whole Europe. This is for the whole continent was researched, and this is obviously you want to harvest this as local as possible.
Yeah.
So no imports.
Okay. No imports. Okay. And how do we get enough timber for this?
If we don't burn this for energy, we have enough. And
really?
And we have to obviously we have to have sustainable forest management.
Okay. I was just suggesting planting on the same field that you use for making the straw, plant hemp and use the hemp for wood to make the wood for the timber.
Yeah, there are so many possibilities, but there are things that can actually happen right now as we speak.
Yeah.
And in 5 years.
Okay.
You know, but you have to. I'm not an expert for hemp, but I try.
Yeah.
Okay,
yeah.
And the whole infrastructure is ready for forest products and straw products. You can do it right now. I mean, I live here. My window is here. You can't see it, but I live nearby this infrastructure. And for hemp, this is not developed yet, not in this scale. And we have to do it. I mean, this is not an end. This is not an or. Yeah, this is an end, right?
That's what I'm saying. Wait, I'm asking myself, how do we get enough timber to do the straw? But if you say that it's just there right now, then really, is it just CO2 credits that are missing? Like if straw is so much better in CO2 total, are there no CO2 credits? Like I still believe that we would actually get free buildings more or less if we just had CO2 credits for better building materials.
Yes, we don't have in Germany. We don't have any incentive, like not on a large scale. So there's no incentives to do this. there's actually that they protect, actually politicians protect actually the conventional construction industry. This is what is happening right now. And yeah, this is what it is. So there's no incentive to do this, and obviously no incentive for reaching the climate targets or staying in line with this. So there's much room for improvement, yeah, and the material is there. I mean, we have 40. Imagine this: we have in Germany we have 40 million ton per year, and this year was a bad year. We have 38 million ton corn. Let's say the you know what I mean, right? For flour and so on.
Yeah.
And the rest is basically soil. Basically 50 to 40% or 60 even is straw. So we have ridiculous amounts of biomass that we could use for long term use instead of like cattle and horses pee on it, right?
Yeah. Okay.
Okay. So a last question. I think we have from Benny Talbot, and then we would close, unfortunately, our discussion round.
Hi, yeah, fascinating. Thank you. I was just wondering if we start talking about taking really large amounts of biomass out of circulation so that we can lock up the carbon, is there a risk to the soil, and have you looked at the impact that will have on soil carbon and soil fertility and kind of the long-term health of the land?
Okay, I see both raised your hands, Eva and Michael. Who wants to start, Eva?
Well, I think Michael has the answer, although I can say in Bauhaus Earth, we are also like doing the studies for this when we are doing now the big global studies. We are also thinking like in like sustainable agriculture and forestry and thinking in the soil, of course, yeah. But maybe Michael, you can add something.
Okay, so you can take, we want to do it right. We don't want to experiment with this. We want to do it right from the start. So we only take 1/3 maximum from an harvest. The rest basically stays on the field. This would be sustainable, and I can show you resources where you can read this. So we don't want to use it all. And I showed you a graphic that we don't have to. We have to use a minimum amount of this harvest. We can't use it all. It's so much. So what are we talking about here? So we're talking about maybe if you want to revolutionize German construction industry, you will use maybe like 3% of the German harvest. I mean, this is a scale, right?
Okay.
Thanks, that's good context.
Okay, so now I would close the discussions. Or Eva, you still raising your hand? You want to add something? The last point?
Yeah, actually, I think it's a very important point. I'm sorry that
no worries.
that I mention again. It's like the costs of bio-based construction, because it's always the big argument why in the end we build conventional buildings and don't use bio-based materials. So of course in the future, at least in Germany, we'll have like the carbon dioxide pricing, which will be around 195 euro per ton of ton CO2, but actually it's not enough. We were calculating also in this facade refurbishment, and it has to be around 2,000 euro per ton CO2 at the moment, that it really is something like cost neutral. So actually what we are also now discussing also with like the policy is that the benchmarks has to be in the German rules, or also in other countries, of course, in the laws, that we have benchmarks for the carbon footprints for the building. And then some materials will be out because concrete or bricks, they have like a high carbon footprint. And then if we have like these benchmarks and we are just allowed to build until this benchmark, automatically the material will change.
Very good point. Thank you. Okay, so I would close the discussion round. I think our takeaway for next module will be to plan a little bit more time for discussions. I think that there are lots of questions, lots of interest in the topic, you know, and therefore we would give more room for this in the future. And then just the last slide to share. Thank you for being here. Oh, sorry. Thank you for being here today, for numerous participants being here, for raising your questions, for the speakers, for your interesting contributions and knowledge sharing. I hope that everyone who was here today will take something, you know, as an inspiration for your work, and also to spread the word about all these climate-friendly ways of renovating, building, and that we will move closer to this 2050 goal somehow, climate neutrality also in the building sector. Just for you, we will have two, like I mentioned at the beginning of our training module, we will have two modules more. So the next one will be on funding opportunities for sustainable renovation. Preliminary date is November this year. So here also you can see other deliverables in our project. We will have at the end of the project EU-wide and formal like EU-wide policy conference. We will have two more EU-wide and formal renovation lunches. All this information you can find on our Serve online platform. Here the link for you if you have interest. We hope so. And yeah, I wish you a very nice day, and thank you once again. And if you have any questions, please don't hesitate to contact us or the speakers. And yeah, I wish you all the best.
Thank you.
Thank you very much.
Thank you and bye.
Bye.